是本质大会。随着信息技术日益渗透到人们生活的方方面面 ，Power Architecture 技术已成为人们日常生活的一部分。今天 ，IC 企业、工具开发商、软件开发商、整机企业共聚一堂，共享 Power Architecture 专业技术最新进展，并交流互动。
And this is another advantage we have in Power.org. We have, like was mentioned, we have all the different companies that bring their expertise from different areas, and all the leadership that Power Architecture has had with multi-core and virtualization since the year 2001, most of that now is very applicable to the embedded world when embedded is going to multi-core and has to use virtualization.
So basically, like you may have two control plane and you may have a couple of data plane. So for data plane application, what happens is if all the packet you don't need to maintain the state, then that's fine. So you can just get the packet to this process, that process, that process, that process, and for sure you get 4x performance, right? Because for you have one core, maybe you can do 1 million packet. Then when you have 4 core, you do 4 million packet because they are highly parallel. But however, in real world, that's not possible. What happens is a lot of the time, this processor is busy, that processor is not, and for the same flow of a networking stream, you may have the first packet go to this device and the next go to that device. Then what happens? They will be out of sequence. So these kind of things in multi-core from Freescale, what we do is we do think about that, and we have another queue manager to manage the flow to make sure that they don't go out. They can go in out of order, but when they go out to the actual I/O port, it doesn't go out of order, out of sequence. So this kind of thing is when you have an application that you know what you're going to do and you know what can help to avoid it, and you implement in hardware, then you may have the benefit of actually 4 core equals to 4x, right?
Yeah, so synchronization and scoreboarding is an important really task and topic area in multi-core based on what you're saying. And it's the same concept. I mean, Power Architecture was one of the first architectures that brought the notion of superscalar architecture to the microprocessor design. And we introduced out-of-order execution, but that same thing that we did at the micro-architecture level is now needed at the macro-architecture level, where you have to keep track of the tasks and how you...
Let me explain. With this system virtualization, it tends to force a change in the way you do things. And other impacts are as well that the hardware and the software teams can work together. The reason for this is that at hardware design, we can now create a software model of that hardware. Now, that software model is in such a state that it can be used by the software engineers at that time. But what it does, it allows the hardware and the software people to work more and more together. So if the hardware engineer is trying to think, do I run this on 2-core or 4-core or 8-core? They can actually test that out very simply in the model, because the model is very easy to change. So what it helps in is you get away from an over-design or an under-design at this very early stage, with collaboration of being able to run the software stack very early on, and that helps the hardware design and the hardware decisions. But the thing here on this, and this is why this game changer is that when you have this model of this hardware, people tend to find that they can change their process, so they actually, instead of doing things sequentially, waiting on the hardware, they have much more opportunity to do things in parallel. So all of these things have a significant, or the potential for a very significant impact in reducing this time to market. This is why it's a potential game changer.